Welcome. This video is going to take a look at the ideas presented in section 1.1, the first part, in Katrina Brown's SL.IB chemistry book. And in the first part of section 1.1, we're focusing on the particulate nature of matter. And early on, chemists realized that chemical changes involve interactions between particles and that these particles have a fixed mass. And what that means is that the mass of the particles does not change during a reaction. The arrangement of the particles or the combinations can change, but the mass or the individual particles themselves is not changing. So stoichiometry is a method we now use to keep track of the number and kind of particles that you have before a reaction, during the reaction, and after the reaction, because we know the kind and number has to remain the same since the particles themselves do not change. They have a fixed mass. So chemical elements are now defined as being a single pure substance made of only one type of atom. And there's 92 natural elements on planet Earth, plus there's about 30 man-made or synthetic, or sometimes called transuranic, beyond uranium, elements. And those elements are made up of atoms, which are defined as the smallest piece of an element to show the characteristic or identifying properties of that element. And we also now know that you can make nearly an infinite number of combinations out of these elements, or nearly an infinite number of compounds. And each element is represented with a 1 or 2 letter symbol that you see on the periodic table. And if you think, well, I've seen some with 3 letters, that means that's simply representing the number it would be. And it's just being held, well, it's still being debated as to whether or not that element actually exists, and if we know enough about that element to actually name it and give it a place on the periodic table. So it's in transition yet. Chemical compounds then are a chemical combination of different elements containing a fixed ratio of atoms. For example, water, it always contains the ratio H2O, 2 hydrogen, 1 oxygen. If it contained a different ratio of hydrogen and oxygen, it wouldn't be water. The physical and chemical properties of a compound are different from the elements that make up that compound. So hydrogen and oxygen both exist as a gas at room temperature, whereas the combination H2O exists as a liquid at room temperature. So the elements that make up a compound are called the component elements, or sometimes referred to as the constituent elements. Most elements in nature are actually found as compounds. There's very few that are actually in their pure or what's called the native form. And compounds then are represented by formulas which show the element symbols along with subscripts to let you know not only what elements are in there, but how many of each element. Chemical equations then use the simplest ratio of atoms as either elements or compounds to summarize what happens in a chemical change. It's unusual to have one of each reactant combined to give you one of each product. More often, you have more than one of some of the reactants and products needed to make the change happen. So we summarize chemical reactions by using a chemical equation which shows the direction of change. Generally, the arrow is pointed from left to right, or shown in the forward reaction. And so then the reactants are on the left side and the products are on the right. The other thing to remember about chemical equations is they have to be balanced, since mass is known to be conserved or not changing. So that means the number of atoms on the left or the reactant side has to be equal to the same kind of number of atoms on the right side. And we use what are called coefficients, or sometimes they're called stoichiometric coefficients, to balance a chemical equation. My quick reviews for balancing a chemical equation is that, remember, the unbalanced equation is called the skeletal equation, and it shows the correct formulas for each reactant and product by assigning the correct subscripts. And you might remember with a covalent compound, there'll be no metals in it, and a covalent compound's name, such as carbon dioxide, tells you what the formula is, CO2. Whereas if you have a skeleton equation with ionic compounds, which contain a metal and a nonmetal, such as iron 3 oxide, then you look up the oxidation numbers and balance the number of electrons gained and lost. And often crisscrossing your oxidation numbers will do this. So iron 3 oxide, a positive 3 iron ion is combining with a negative 2 charge on an oxygen atom. So the correct formula would be Fe2O3. A chemical equation, by definition, then has to be balanced by the use of the coefficients. So you use the subscripts to set up your skeleton equation, or the correct formulas for each reactant and product, and then you actually balance the equation by the use of coefficients. And I recommend using a RALP table where you have the reactants on the left side of the table, the products on the right side, and you list the symbol of the atoms involved in the reaction down the center. And then you can keep track of the number of atoms on each side of the reaction. Also a reminder to keep in mind the acronym MINO when deciding what order to balance the elements. You balance your metals, then your ions, then your nonmetals, and then oxygen and hydrogen in either order, depending upon which one might be a free element in your equation. And then the last part of 1.1a, they talk about mixtures. So remember, a mixture contains 2 or more substances, so an element or a compound, in which no chemical combination has occurred. So elements combining chemically form compounds, but elements or compounds simply mixing together physically is called a mixture. So the composition of a mixture is not fixed, so salt water can have a little salt in it or a lot of salt. And each substance retains its characteristic property. In salt water, water remains a liquid. Even though the solid seems to disappear or spread out, it still has that salty or characteristic taste to it. And then a mixture may be uniform throughout, which is homogeneous or homogeneous, or it can be non-uniform and the properties vary throughout, and then it's called heterogeneous. And again, mixtures can be separated by physical means since they're just physically combined. And you can separate mixtures using things such as solubility in water, would allow you to filtrate something that doesn't dissolve from something that does dissolve. You can use boiling point, which is something called fractional distillation, and each substance would boil off when it reaches the appropriate boiling point. You can use magnetism to sort some metals. You can use adsorption to the solid phase in something called paper chromatography. You maybe remember doing this with water-soluble pens. Or you can use something called gel electrophoresis, uses the net charge that's on an ionic compound at a certain pH or at a fixed pH. And that summarizes the first part of section 1.1.